Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.5, Problem 7. This is Section 15.5, Problem number 7. It says, find the area between the function f of x equals 2x squared shown in red and g of x equals 2x plus 4 shown in blue. So just to be very clear, the function shown in red, 2x, let's do it in red, 2x squared. That's the more curved one, f of x equals 2x squared. And g of x equals 2x plus 4 is the straight line in blue. So the question is asking us to find this area, this trap between those two functions, the red and the blue. So looking for that area. So problems like this are solved by finding a definite integral of the top minus the bottom, and I'll put a dx on that. So for the amount of trapped area that we're looking for, the top graph is the straight line, the blue one, which is 2x plus 4. Minus the bottom graph, which is the red curved graph, which is 2x squared. I'll close the parentheses, put a dx on the end. But it's a definite integral, so we need to have our limits of integration. We need to know what those are. So one point where they intersect is in kind of the lower left, and then there's another point where they intersect in the upper right. And the graph is drawn accurately enough. You can read it off the graph. So the upper left one is over 2 for the x and up 8 for the y. And the one in the bottom is going to be back 1 and up 2. So the back one, you have to be careful. It's minus 1 for the x and then up 2 for the y. So now with our limits of integration, it's going to be the x coordinates. The y's don't matter. Our limits of integration are going to be positive 2 and negative 1. And you want the larger of the two values, the positive 2, to be the upper limit of integration, and the smaller of the two, the minus 1, to be the lower limit of integration. So now I have a definite integral that I can use 4 steps to solve that will find the area shaded on my graph. So the first of 4 steps to solve a definite integral is actually do the integral. So the 2x squared can be thought of as 2x to the first. It'll have an integral of 2 over 2x to the 2. The 4 will have an integral of 4x. The minus 2x squared will be minus 2 over 3x to the 3. There is a plus c, but I know at the very end it would cancel, so I don't even write the plus c. And I can simplify the 2 over 2x squared. Let's just call that x squared. And I'll leave the rest of it the same. I'll leave the 4x. I'll leave the minus 2/3 x cubed. And I'll put a long vertical line after my answer for the integral. And I'll put my limits of integration in, positive 2 as the upper limit and minus 1 as the lower limit. So that's step 1. I solved the integral. Step 2, put in the upper limit of integration for x, or whatever your variable is. So the x squared will become 2 squared. The 4 times x will become 4 times 2. The minus 2/3 x cubed will be minus 2/3 2 cubed. So let's go ahead and do the math for that. 2 squared will be 4. Then 4 times 2 will be 8. And then 2/3 2 cubed, it'll be minus 2/3 2 cubed is 8. So the 4 plus 8, let me just make that a 12 right now. And then 2/3 times 8 we can write as 2/3 times 8 over 1. Let's write the 8 as an 8 over 1 so it has a numerator and a denominator. And then I can multiply. Top times top, 2 times 8 is 16. Bottom times bottom, 3 times 1 is 3. that's being subtracted. The 12 I will convert into a 36 over 3. That'll still reduce to 12, but written this way, I have a common denominator. I have two fractions, they both have a denominator of 3. I'll subtract 36 minus 16 on the top gives me a positive 20 over 3. So that's the answer for step 2. When I put the upper limit of integration into my answer for the integral, I get a result of 20 over 3. So now step 3, take the lower limit of integration, the negative 1, plug that in for x in my answer for the integral. So the x squared would be negative 1 squared. The 4 times x will be 4 times negative 1. And then the minus 2/3 x cubed will be minus 2/3 negative 1 cubed. So be careful with your signs. You have a lot of negatives here. Negative 1 squared. So negative 1 times negative 1, positive 1. The negatives cancel. 4 times negative 1, I'm going to have a minus 4. Then I'm going to have minus 2/3 times negative 1 cubed. So it's an odd power. Negative 1 times negative 1 is positive 1. Times the third negative 1, we'll put it back to negative 1. So 1 minus 4 is negative 3. And then negative 2/3 times negative 1 will be plus 2/3. So let me write the 3 as 9/3. So negative 3 can be written as negative 9/3. That's still negative 3, but this way I have a common denominator. So negative 9/3 plus 2/3. Common denominator is 3. The numerator is negative 9, positive 2 is minus 7. So now I have a result for my lower limit of integration. The final step is to subtract my result from step 2, the 20/3, minus the result from step 3, the negative 7/3. Notice the two negatives. One of them because you're supposed to subtract. The second negative is because the result from the previous step was negative. So that can be canceled, the negatives, and make it 20/3. The minus a minus 7/3 becomes plus 7/3. 20/3 plus 7/3 is 27/3. And this big, long, messy problem surprisingly reduces down to a whole number of 9. So the area between the red graph and the blue graph is an area of 9.